Assalamualaikum warahmatullahi wabarakatuh. Okay, today our group will present the krichoff law and series parallel circuits. This is our lab report that we will present, which is lab 3. Okay, this presentation will be carried out by me, Muhammad Rizwan bin Sutimin, AA 190285, Muhammad Shalihin bin Nordin, AA 191350, Muhammad Shamil, AA 190676, Muhammad Yunus Nabil bin Abdul Latif, AA 190648, and Muhammad Zarfan bin Rustam, AA 191545. And let's begin.
Hello, my name is Muhammad Yunus Nabil, matrix number AA 190648. I'll be talking about the additional theory for lab 3. A resistor is any form of diode or circuit addition that provides a certain resistance to the circuit. In short, the resistance of a circuit can be calculated using the Ohm's law, which is V equals to IR, where either one of the constant has a constant value or fixed value. A circuit has two types, which is both parallel or a series circuit. This depends on how the diode or the resistor is placed in the circuit. If it is next to each other, it forms a series circuit. But if it branches off into two or more paths, then this is called a parallel circuit. When a circuit branches, it will have a node, or you can say where the wire branches from. So it forms three or two paths. So Kirchhoff current law states that the algebraic sum of the currents entering any node is identical at any instant of time. So the input is equals to the output of the node. And also that the Kirchhoff voltage law states that the algebraic sum of the voltages around any closed path in a circuit is identically zero for all the time. So that means that the voltage is totally dependent of the voltage polarity encountered along the closed path. So where the voltage enters, and when it passes through the resistors and outputs back, circles back to the original, to the power source, the sum of it all is zero, as stated by the Kirchhoff's law. And Ohm's law supports this because the resistance is equal to the product of both current or you can say the voltage is the product of both resistance and current. So that is all for the additional theory.
Assalamualaikum. So, the objective of this lab is identify relationship between the sum of the voltage drop across a series of connected resistor and the applied voltage according to KVL. Second, identify the relationship between the sum of the current entering any junction of an electric circuit and the current leaving that junction according to KCL. Differentiate between the series and parallel circuit based on the total current flow and total voltage drop. First of all, this lab have two tasks for students to do to start the experiment. Task 1 is Kirchhoff voltage law and series circuit. First, we need to measure the resistance of the 2.2 kilo ohm, 4.7 kilo ohm and 5.6 kilo ohm resistor using the multimeter. Second, using the multimeter, measure the node voltage VA, VB and VC with respect to ground. Third, measure the current of A, B and C. Lastly, record all your measured data in table 3.1. For the next task is Kirchhoff current law and parallel circuit. First of all, build the circuit as shown in figure 4 at in the lab sheet. Second, measure voltage AB, DC, B and C. Measure voltage B and C with respect to ground. Third, measure the current of 1, 2 and 3. Make sure that all current value satisfy the KCL rule. And last, record the measure data in table 3.2. Thank you.
Okay, Assalamualaikum, and I will present our result in this lab report. My name is Muhammad Rizwan bin Sutaimin, 88190285. Okay, first we discuss about the series circuit. Okay, in this series circuit, it consists a transistor. Okay, what we measure is the voltage and the current. As you can see in the table 3.1, the voltage value is different, but the current value is the same. Okay, let's see why it's happening to this circuit. Okay, actually the value of supply voltage is 10 volt. Every voltage taken is depend on component in the circuit. The total of the voltage at the three resistors should be equal with the total voltage supply. So if the resistor is in series with some other elements and they together by a constant voltage source, then the voltage drop across the resistor means there less voltage available for this other circuit elements. The amount of current A, current B and current C is look similar because the amount of current in a series through any component in the circuit. This is because there is only one path or for current flow in a series circuit, which is the value of voltage is different because of the component, which is the resistor that we used, and the current value is the same because of the current is go through in a one path. They did not divide into two way or one the other ways. Okay, let's move to the other result, which is in the parallel circuit. As you can see in this circuit, the voltage value is the different and never be the same with the others, and also the current value is also different with the other. It's not similar. So why is it happen? Okay, the value of voltage B is higher than voltage B plus C. It's because of the resistor at VB is actually playing an inverse role, which means it's make the voltage higher, not lower. The current value is different and current 2 is the higher because the value of the current is multiply the value of the resistor, and it's meant when parallel circuit are classed as current dividers, since there are multiple paths for the supply current to flow through, the current may not be the same through all the branches in the parallel networks. So in term of this circuit, when the resistor is organized in a inverse than what it should, so the resistor will play the inverse role, which is it will make the voltage higher, not lower. So that's why the voltage there is higher than than other resistor. Okay, the current is different because there is a node that divide the total of the currents. So the total current of each branches is not the same. So that's why the value is not the same. So thank you. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. So I will present part question and discussion. For question A, discuss how to theorem of KVL and KCL AC used to verify the answer obtained in the experiment. Okay, the the answer for this question. In theorem of KBR, it shows that the sum of voltage resistance or drop around every loop of the circuit will KCI show that the sum of the current at each specific road in circuit. Each theorem have a formula with I1 I2 plus I3 and total sum of voltage equal to 0 for KBR and KCR. Both are not followed by multiple voltage or current source of parallel resistor. So it's easy for us to solve a problem in the experiment. Okay, for question B, from figure 9.7 above, find the current flowing through resistor 1 k ohm. All the calculate step. So you can see the calculate how to calculate ohm in the circuit. So the calculate like this.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarfan Mirostam, and now I would like to conclude the lab report for Krichoff law and series parallel circuit. The purpose of this experiment was to verify Kirchhoff current and voltage law. One can see from the data and explanation provided that this purpose was met. When the current going in and out at node B in figure 3.5, the sum was approximately 0. While we can see also when the voltage around the loop of figure 3.6 were added together, the sum also was approximately 0. Kirchhoff's law therefore was to be correct. The data collected did not come to be exact due to some error when using different devices. We also gained some experiment skills such as how to use breadboard, setting up resistor into series and parallel, and much more. I think that's all from us. Thank you.